All right, we are going over the practice test for the Unit 2 and 3 exam. So let's get started here. What happens to the electrons in each of these types of bonds? Okay, so we've been talking a lot about covalent bonds lately, and those are bonds in which electrons are being shared. That's why we always draw the line between the two dots. Some properties of elements with this bond type. This should really say compounds or molecules. Just going to fix that really quick here. Okay, so some properties are, this is back from Unit 2, they have a low melting point, they smell, they're typically liquids and gases. That's much different from ionic bonds where an electron is transferred from a metal to a non-metal. Remember, this is something like sodium chloride, where sodium gives up its outermost shell electron to chlorine. And then sodium's got a positive charge, chlorine has a negative charge, and that's why they stay together. So think about salt. What do you know? They dissolve in water. They have a high melting point. They conduct electricity when they're aqueous, meaning when they've been dissolved in water. Not as a solid, but once you throw some salt in water, that water is conductive now. Network covalent, there is also a sharing of electrons between nonmetals. Okay, these are a little bit tighter in the way that they're shared though. So they end up having a really high melting point. You might remember the picture. It was like that quilt. These are the boring ones. They don't dissolve, they don't conduct, they don't smell, they don't do anything. Metallic, it fills this one in for you. There's the sea of electrons. So a bunch of metals bring their electron and they move all about. Okay, metals have a high melting point. They're hard to melt. They don't smell, they don't dissolve. Think about like a copper penny. All right, so what type of bonding forms molecules? Things that are covalent form molecules. Lattice structures come from things with ionic bonding. Okay, and you might be saying to yourself, what is a lattice? Well, it's an organized crystalline structure of repeating patterns of atoms. Okay, so I'm trying to draw one here of like a sodium chloride. It would be like a big cube that repeated these atoms over and over. Molecules, for example, oxygen gas. That's just two oxygens that are bonded together, and these are gas. They kind of fly free. These are atoms that are held more tightly together. Okay, not that these aren't held tightly together, there's just more of them in a big block. That's what a lattice is. What kind of bonding would these examples have? NH3, it's all nonmetals, so it would have covalent bonding. It's also a gas. That gives you a clue that it's not ionic or metallic. NaCl, that's a metal and a nonmetal. Automatically, that means it's ionic. Name any elements that will combine with calcium in a 1-to-1 ratio. Well, calcium is in group 2A. That means it's got 2 valence electrons, and it would like to lose 2 in order to be stable. So it would form a 1-to-1 ratio with anything that would form a -2 charge. So you could say anything in group 6A, for example, oxygen. How many bonds would a bromine form? A bromine atom would form bonds to get how many total valence electrons? Everything wants the grade 8. How many lone pairs would a selenium atom have on it in SeH2? So let's draw Se with the 2 H's, and it would have 2 sets of lone pairs. 2 lone pairs. This is a lone pair right here, and this is a lone pair right there. All right, moving on to number 4. gives you an element. Will this gain or lose electrons? Okay, so sulfur is in group 6A. It would like to be like neon. It's only 2 away. I'm sorry, it would like to be like argon. It's only 2 away, and it'll have 18. It's got 16 electrons. It wants to be a noble gas. So it would like to gain 2 electrons, and when it does that, it'll form sulfur with a -2 charge. Aluminum would like to lose 3 electrons to be like neon. So if something loses 3 electrons, it's going to form a positive charge. Let's go over why that is again. Aluminum's got 13 positive protons in its nucleus. Normally it's got 13 negative electrons in its cloud. Well, if you lose 3 electrons, now it's only going to have 10 electrons. 13 positives and 10 negatives. The positives are winning by 3. In what circumstances would you use a Roman numeral? You only use Roman numerals when you're naming transition metals. What does the Roman numeral represent? It represents a positive charge. So for example, a 1 is a positive 1. A 2 is a positive 2. Okay, 4 is the weird one. IV, that's a positive 4. So what would the charge of the transition metal be in the following compounds? FePO4. PO4 you should recognize as a special polyatomic ion that has a -3 charge. That means Fe would have a +3 charge to cancel it out. +3 and -3 makes 0. Number 2 is a little trickier. It takes 3 coppers to cancel out 1 phosphide. That phosphide has a -3. So what charge must each copper have? A +1. So you would name this copper 1 phosphide. Number 6, name these. The first one's easy. Sodium oxide. I say easy because there's no transition metal. So we don't need Roman numerals. Number 2, we've got a transition metal. So I'm just going to write copper, leave it empty so I don't forget it, oxide. Now I got to look up at the second thing. What charge does oxygen always have? It's always a -2. That must mean copper is a +2. So that would be copper 2 oxide. Number 3, you should recognize SO4 as one of the 6 polyatomic ions. You do not have to have those memorized. So potassium sulfate. Number 4 is also straightforward. Aluminum is not a transition metal. So aluminum chloride. Here we've got a transition metal again. So iron, leave a space, carbonate. This is going to become iron 2 carbonate because carbonate always has a -2 charge. If you don't know that, it's one of the 6 polyatomic ions and you'll be given those. Okay, and the last one is straightforward, no transition metal, so we just name it. OH is one of those special 6 polyatomic ions, so that's calcium hydroxide. Now we're switching gears and we're crisscrossing to write compounds. So remember when you do this, you write the charge above each. So look at the orange post-its if you're in the classroom. So NA's got a +1. Phosphate's one of the special 6, that's a -3. So this would be Na3PO4. Aluminum's a +3. Nitrate is a -1. So this is AlNO3-3. Number 3, Fe is a +2. Cl is a -1. So FeCl2. Copper's got a +1. Sulfur's a -2. So that's Cu2S. Ammonium is NH4 with a +1. Bromine is -1. So that one you can just slap them together. NH4Br. Tin's got a +4. Oxygen's a -2. You might be saying, wait a second, tin's not a transition metal. Well, it is one of those weird ones that can have multiple charges, so it's kind of an exception. Not kind of, it is. SN2O4 Is that the best you can do? You can simplify that. So it should be SNO2. All right, now you've got some structures to draw, and you're supposed to name the functional group. So C3H6, I'm going to put my double bond to my oxygen in the center here and just see how this works out. 1, 2, 3, 4, 5, 6. Don't forget the lone pairs on your oxygen. And that is a ketone. Second one down, C2. I know I need 2 oxygens here. And I've got 3 more hydrogens to put in place. So this is Cu, and I gotta add my lone pairs. That is a carboxylic acid. This one kind of gives it away in the name. So we've got carbons and a nitrogen, and then we need our hydrogens to all make sense. So we need our carbons to have 4 bonds, and our nitrogen to have 3. That is an amine. Ester is a kook, so I'm going to do C double bonded to an O, O, C, and then I'm going to add 4 more carbons. 1 hydrogen, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's going to work out for my ester. Ooh, and in the last one, I forgot my lone pair on my nitrogen. That would be a -0.5 point. Shame on me. Don't make my mistake. All right, number 9. Draw the Lewis dot structure. Since nitrogen is in group 5A, it gets 5 dots. 1, 2, 3, 4, 5. How many bonds would it form? Depends on how many lonely electrons, so it would form 3. Silicon is in group 4A, so 1, 2, 3, 4. It would form 4 covalent bonds. Neon's in group 8A, so 1, 2, 3, 4, 5, 6, 7, 8. It would form 0 covalent bonds because it doesn't have any lonely electrons. Number 10, we're supposed to draw 2 isomers for these. So let's see. C2, I'm going to put the chlorines on different carbons in one of my drawings. Okay, these are where my hydrogens are. Okay, you would want to definitely draw those in. I'm going to test. Okay, and then I'm going to do one where I put 2 chlorines on the exact same carbon. That is a different shape. And then my hydrogens would go there. How about C5H12? I can put all my carbons in a row, or I could do 3 in a row and 2 going down, for example. It's actually 4 in a row with 1 hanging off the second one. Okay? There's another version here too. You can have 1 going up, 1 going down. All right, make sure you draw in your hydrogens on the actual test. I'm being bad right here. All right, last page. Woohoo! Complete this table. So we're going to draw the structural formula. So let's see. Nitrogen's got 5 dots. Fluorine's got 1, 2, 3, 4, 5, 6, 7. Boom. 1, 2, 3, 4, 5, 6, 7. Boom. 1, 2, 3, 4, 5, 6, 7. Boom. CS2, let's check it out. Sulfur's got 2 lonely electrons. I'm going to make it symmetrical. It's always a good tip. Boom, 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 boom. Okay, and you'd want to draw that nice and neat like I did on the answer key. Let's see here. We've got C, N, and then we've got Br3H2. You can put these anywhere. Like I did this different on the answer key, but I'm going to put my bromines here just to be different. And then I'm going to put my other third bromine here. And then here's my 2 H's. H2S, that's kind of like H2O. Sulfur's got 6 valence electrons. So those 2 lonely ones form a bond with hydrogen. C2, Cl2. Let's make our molecules symmetrical. Let's set ourselves up here, connect everything at least once. And then I see right away I'm going to have to make this a triple bond. CCl4, put your C in the middle, surround it with your 4 chlorines. It's a lot of work to draw all those lone pairs, but you need to do it. 12, match the chemical formula with its name. This is going to be copper, leave a space, phosphate. So phosphate's a -3. That means this must be copper 3-phosphate. So that would go with letter C. Number 2, aluminum is not a transition metal. So that would match with E. You do not want the parentheses here like they show you in D. Number 3, hydroxide's a -1 charge. This nickel is canceling out 3 negative ones, so that must mean this nickel has a +3 charge. Number 13, more tricky formulas. Magnesium hydroxide. Mg's got a +2. OH is a -1. So you need parentheses around it since it's more than 1. 1 goes with B. Sodium sulfate. Sodium's a +1. Sulfate is a -2. So it's Na2SO4. And the last one, copper 1 phosphide. Not phosphate. Crisscross, it's just Cu3P. So letter F there and letter D on that last one. All right, I hope your studying is going well. You can always come in and get some extra help in the exam review session.